So, student, the next content is method of preparations of haloalkanes. Okay, in this video we are observing what method of preparation of haloalkanes only. So, haloalkanes, these are not R and X. Earlier I told you the R, X are actually derived from corresponding alkanes, but besides of it we can also derive or obtain haloalkane by some more different method. So the first method is from alcohols. Alcohols, that is what? ROH. Okay, where alcohols are different type of alcohols. Therefore, I am writing alcohols are treated with hydrohaloic acid. Hydrohaloic acid. Hydrohaloic acid means H and or halogen. This is what? X. This is called hydrohaloic acid. Okay. In the presence of anhydrous, zinc chloride, okay, which act here as what? You can call it what? For some time catalyst. Actually it acts as coordinate compound, but we are writing here catalyst. It require only for primary and secondary alcohols. Okay, not for all alcohols. That is not for tertiary alcohol, but it requires only for primary and secondary alcohol. We will see how it is. So, any of the alcohol, say ROH, when react with hydrohaloic acid, this is what? HX. Okay, so the reactant part we can show in this way, HX in the presence of ZnCl2. I told you for primary and secondary it gives R and X. This is haloalkane plus H2O. Isn't it? This is the most convenient method for the preparation of haloalkanes. Okay. The reactivity order of alcohols are primary alcohol is least reactive, secondary alcohol is moderate reactive, but the tertiary alcohol reacts very fast. So this is the reactivity order, and the reactivity order of hydrohaloic acid, okay, or the least reactive is HF, the more reactive is HBr, the more reactive HCl, and the most reactive one is what? Hydroiodic. Now, what is the reason behind the reactivity? So to check it, we have to see the mechanism. Okay? The above reaction is type of nucleophilic substitution reaction. Nucleophilic substitution reaction. Okay. Now nucleophilic substitution reaction means here OH. Okay. will substituted by the X. So this is called nucleophilic substitution reaction. We can check the mechanism. Actually, in first state, R, O and H. Getting O has lone pair which reacts with H of HX acid. That is the lone, that is the proton is accepted by the alcohol. Therefore, in first state, it forms R, O, H, and now due to donation of electron that become OH2. There will be plus sign, remaining only one lone pair. In second state, these are O and this is what H and this is again what H and this is one lone pair with what plus charge. Now the X anion released by HX is getting attacked on what? R. Why? Because now there is an electron deficiency, so the bond pair is accepted by what? Oxygen. And we know that water is a better living group. So when the water will left, then there will be remain only what? R in the form of what? Cation. And in this cation, now the X anion can easily attack by forming what? H2O. Isn't it? So this is the mechanism. Now as you can see here, the formation of carbocation takes place, which can be called as electrophile. So in this electrophile, the nucleophile X anion, you can call it what? Nucleophile X anion can easily attack. Therefore, the reaction is nucleophilic substitution reaction. Now, student, why do the tertiary alcohol is most reactive? The tertiary alcohol is most reactive. This is because the tertiary alcohol will form tertiary carbocation, and you know that the tertiary carbocation is most stable. Therefore, the order of reactivity of alcohol is what? 1 degree, 2 degree and 3 degree. Because the most stable 3 degree carbocation will form. Similarly, the order of reactivity of HX. So why do HI is the most reactive hydrohaloic acid? It is because the HI can break very easily because it is known as the strongest hydrohaloic acid. Isn't it? So the I can attack very easily, that is I can donate its lone pair to the carbocation very easily. Therefore, HI is the best one. Now, what is the role of ZnCl2? Okay. So, ZnCl2 act as coordination compound. Which donates, which you can call it what? Coordinates, which coordinates with what? Oxygen of OH. Oxygen of OH. So COH bond becomes weak. This bond becomes what? Weak. And therefore, the cleavage of COH bond becomes very easy. This is the role of ZnCl2. Remember, ZnCl2 require only in the case of primary alcohol and secondary alcohol, not for tertiary alcohol. Because tertiary alcohol is so reactive that it can directly react with hydrohaloic acid to form haloalkanes. Yes, student. In previous video, we have seen the use of hydrohaloic acid and zinc chloride in the case of preparation of haloalkane by primary and secondary alcohol. Student, in very earlier video I told you, you can be asked the question from distinguished taste of different types of compounds. That is, compare one compound with another compound, how will you distinguish it? So we are having one of the very important distinguished taste. This is called Lucas agent or Lucas reagent. So what is Lucas reagent? It is the mixture. It is the mixture of HCl and anhydrous ZnCl2. Okay, it is used to distinguish primary, secondary and tertiary alcohol alcohols. Okay, how? Okay, so first one, when tertiary alcohol, okay, reacted with Lucas reagent. Now what is Lucas reagent? Lucas reagent is the mixture of HCl and ZnCl2. So when tertiary alcohol reacted with Lucas reagent, it forms turbidity. Okay, within 5 minutes. That means what? The reaction takes place so fast. Why? It is because I told you earlier that the tertiary alcohol reacts very fast. So the turbidity, that is the product obtained, is very quick. That is what? Within 5 minutes. Number B, secondary alcohol forms, okay, from 5 to 20 minutes. This is the difference. That is, the reactivity of secondary alcohol is little less as compared to tertiary alcohol. Therefore, the desired product obtained after 5 minutes, that is say 5 to 20 minutes. But you know that the primary alcohol is least reactive. So primary alcohol forms turbidity. What? After 20 minutes. So it makes the difference. That is, in this way we can differentiate primary alcohol, secondary alcohol and tertiary alcohol. That is on the basis of the reaction. Okay, slow, moderate or fast. So tertiary alcohol reacts very fast. Within 5 minutes, the desired product gets obtained. Secondary alcohol requires 5 to 20 minutes, but the primary alcohol reacts very difficultly and forms turbidity after 20 minutes. So it makes the difference. So this is about the Lucas reagent. Now, student, compound to compound, that is which type of haloalkane we have to prepare. Like suppose we have to prepare what? Chloroalkane. Then ROH should be treated with what? HCl. in the presence of what? ZnCl2, where it will form RCl plus H2O. In earlier reaction we have already seen, if we have to form bromoalkane, okay, then CH3 CH2OH is treated with HBr. HBr, this is what? 40% HBr in the presence of little, that is very less quantity of H2SO4. H2SO4, where it forms CH3, CH2 and Br. Okay, but if you prepare iodoalkane, then CH3, CH2OH is reacted with HI acid. This is what? 58% HI acid. Okay. So with HI it forms CH3, CH2, what? I, that is iodoalkane. Student, we can also prepare iodoalkane using like CH3OH plus Ki. That is, we can also use here what? Potassium iodide. Potassium iodide. Okay. Here it forms CH. Yes, student. Next one is preparation of haloalkanes using alcohols and phosphorus halides. Now, student, phosphorus halides are of two types: phosphorus pentachloride and phosphorus trichloride. So first I am writing the reaction. When alcohol ROH is treated with phosphorus pentachloride PCl5, it forms RCl. This is RCl plus POCl3 plus HCl. And similarly, we can write ROH plus PCl3. This is called phosphorus trichloride. Again, it forms RCl plus. But student, now here with PCl3 reaction, we require 3 molecules of alcohols. Okay, so when 3 molecules of alcohol react with it, it forms 3 molecules of 3RCl plus form H3PO3. Okay, we have one more method, third method, preparation of haloalkane by refluxing. Student, it is one of the very important terms which we are using in the chemistry. Refluxing means what? Liquid substance is first evaporated, okay, and then it is condensed back to liquid form. This is called refluxing process. So preparation of haloalkane by refluxing alcohol and then treating it with thionyl chloride, okay, chloride in the presence of pyridine solvent. Now, how the reaction takes place? ROH reacted with thionyl chloride, that is what? SOCl2. Okay, this compound is known as thionyl chloride in the presence of pyridine. It forms RCl plus SO2 plus HCl. Now, student, this is the most convenient method. Okay, to prepare pure chloroalkane. You can write it what? Chloroalkane. Okay. Why? It is because the two byproduct obtained, one is SO2 and one is HCl. Okay, they obtained in gaseous form, that is vapor form. So these byproduct gets evaporate quickly, therefore we get the pure RCl. Therefore this is the most convenient method for the preparation of haloalkane. Yes, student, next one is preparation of haloalkane using unsaturated hydrocarbons. Unsaturated hydrocarbons means we can use alkenes or we can also use alkynes. That is, multiple bond containing hydrocarbons are called unsaturated hydrocarbon. So here the first method is a reaction of ethene, okay, with HBr hydrobromic acid, okay. So you know that what is the ethene? Ethene is a double bond containing compound. When it is reacted with HBr, now HBr, there is H cation and Br cation. So one of the H enters here and the Br attacks here. Thus it forms bromoethane. You can see here. It forms what? Bromoethane. Student, this is very simple addition reaction which we have observed in previous class. But related to this reaction, there is one of the very important reaction. This is called unsymmetrical propene, that is alkene propene. Okay, when reacted with HBr acid in dark, that is, you can say absence of any catalyst, okay. I am using the term absence of any catalyst because you will see its role in next reaction. Absence of any catalyst, then addendum. The addendum is known as Br anion, is added to that carbon of propene, which have least number. I am writing using what? Capital letter. Least number of hydrogen atom. Thus forms two bromopropane. Like here. Now unsymmetrical alkene, that is, you can say what? Propene. This is called unsymmetrical alkene. That is, odd number of carbon atom is present. This is called unsymmetrical alkene. You can write it what? Propene. Now look at, in the first carbon atom there is 2 hydrogen, in second carbon atom there is 1 hydrogen, and in third carbon atom there are what? 3 hydrogen. So which have least number of hydrogen? Obviously these carbon have least number of hydrogen. So when HBr acid is reacted with it, say HBr, then according to the reaction, the Br added to that carbon of alkene which consists least number of hydrogen. So these carbon consist least number of hydrogen, therefore the Br will attack on this carbon atom, forming two bromopropane. Look at here. The hydrogen will attack here, and the Br will attack here. It is because it has only one hydrogen, while it has two hydrogen and it has three hydrogen. So the 2-bromopropane will be the major product. Now the question is why? The question is why? So it is due to the Marconi-Cauchy rule. This is due to what? Marconi-Cauchy rule. According to Marconi-Cauchy rule, the reaction, the mechanism proceed by the formation of carbon, by the formation of what? Carbon intermediate. I told you that it is very important to revise the reaction intermediate. Formation of carbon. Okay. So propene produces what degree and 2 degree what? Carbon. Okay. And 2 degree carbon is more stable. Okay. Therefore what? The Br will attack on carbon, which will be what? Secondary carbon. So here there will be secondary carbon and thus Br will attack here. The described mechanism we have seen in class 11th, just 1 or 2 months before. Yes, student, next one is by halogen exchange. In this reaction, first we will see Finkelstein reaction. Halogen exchange means what? The two reacting compound containing halogen and then the halogen will exchange. This is called halogen exchange method. When chloro or bromo alkane is heated with sodium iodide in the presence of acetone. Look at this student. Rx. Here X should be Cl or what? Br. That is smaller halogen. When heated with NaI. Now Na and what? I. Sodium iodide. You know that iodine is bigger in size, sodium is smaller in size. That means what? The bond length is very high, bond dissociation energy is very low. So I should be the better living group here. When it is heated in the presence of acetone, then the halogen is getting exchanged, means Cl or Br and I is getting exchanged, thus forming I, that is iodoalkane plus Rx. Okay, so this is one of the method. It is very important method. Often it is asked against 1 mark. Okay, it's a second reaction. This is known as, again it is the name reaction called Schwarz reaction. Called what? Schwarz reaction. Now, to prepare chloroalkane. Student, in earlier method, we have learned how to prepare chloroalkane, bromoalkane, iodoalkane. But still one of the reaction, that is one of the halogen. Okay, haloalkane is remain, which is what? Fluoroalkane. Student, the fluoroalkane cannot be prepared by direct method because chlorine is extensively reactive. Therefore, it is reacted according to Schwartz. When alkyl halide, now this alkyl halide again may be what? Cl or Br. Okay, when reacted with silver fluoride. Look at here, metal is there, silver metal is there, but if it attaches with the silver metal, then its reactivity gets ceased because some quantity of covalent bond formation takes place here. That is, it is not a perfect ionic compound. Okay, then silver forms what? Fluoroalkane. Okay. So RCl, you can also take Br plus AgF. It forms RF plus AgCl. So student, it is one of the very important reaction. One more reaction is there. This is called number C. Reaction is called Hunsdiker reaction. Okay. Now, what is Hunsdiker reaction? It is often asked against one mark. The reaction involved silver salt of fatty acid. Silver salt of fatty acid. You know what is the meaning of silver salt of fatty acid? Okay, it is long carbon chain containing carboxylic acid. This is called what? Silver salt of fatty acid. Like here, you can see CH3, CH2, COO, and what? Silver. I am directly writing equation. Okay, I am not writing equation here. We can call it. What is the name? Silver propanoate. Okay, silver propanoate. Then this silver propanoate, okay, that is called what? Silver salt of fatty acid, is treated with bromine. Okay, in CCl4 flux. CCl4 flux, it forms CH3, CH2, Br. Okay, plus CO2 plus AgBr. Okay, so this is Hunsdiker method. So what is Hunsdiker method? When silver salt of fatty acid is treated with bromine in carbon tetrafluoride flux, it forms bromoethane. You can write the name bromoethane. Okay, by release of carbon dioxide gas and formation of pale yellow PPT of silver bromide. Yes, student, next one, method of preparation of haloalkanes. Arenes. Before it, we have observed alkanes preparation. Now we are doing haloarenes. Student, one of the very important reaction belonging to it is known as Sand-Meyer's reaction. Student, this is very important reaction. Okay. It is because the reaction is not only utilized for chapter first, that is in this chapter, but in nitrogenous compound it also plays a very important role where one complete content is given, okay, about the reaction. That is, in this reaction, one of the reactant which required, this is called benzene diazonium chloride salt, to which we are preparing by aniline, and aniline belongs to nitrogenous compound. So in fourth chapter there is the whole of the compound. Even the benzene diazonium chloride salt, which is in short called diazonium salt, it is used to prepare cyanobenzene, used to prepare phenol. That means what? In 3 chapters the reaction can be utilized. Therefore, you have to pay proper attention in it. What is Fenway reaction? When aniline is reacted, aniline is reacted with mixture of sodium nitrite NaNO2 and concentrated HCl. Remember, HCl should be what? Excess. That is approximately 3 moles of HCl. Okay. At very cold atmosphere, very cold solution. Okay, say it should be what? 0 degree to 5 degrees Celsius. Remember, we must have to maintain this temperature whenever the reaction will take place. Otherwise, the product will form but will be what? Explosive and highly unstable. So, to prepare diazonium salt, we require this condition. So, when aniline is reacted with mixture of sodium nitrite and concentrated HCl, which should be in larger quantity 3 moles, and all these 3 substances must be remains in cold solution. That is, we have to use their cold solution. Then it forms benzene diazonium chloride. Benzene diazonium chloride. Student, this process has a specific term. This is called diazotization. So first it for benzene diazonium chloride. Benzene diazonium chloride when prepared with CuCl to prepare chlorobenzene, or CuBr to prepare homobenzene. Okay, forms chloro or homobenzene. Therefore, it is most important reaction. Now, you can write the reaction when aniline. Okay, this compound is known as aniline. Okay, repeatedly I am telling you, you must write the name of reactant aniline when treated with sodium nitrite plus HCl. Okay, HCl should be in excess and the temperature must be 0 degrees Celsius to 5 degrees Celsius. Student, you know, when you are going to identify NO2 anion, and as soon as you add HCl, okay, very fast the red brown color gas of NO2 is getting evolved. But here we have to seize this gas, okay, in the form of, and it should remains in the form of nitrous acid, and therefore we are using what? NaNO2 plus HCl, but which type is cold. Means HCl again it will be what? Very cold, so that NO2 should not evolve and should not release out. Okay, therefore we are using this temperature. It forms benzene diazonium chloride salt. Now what is benzene diazonium chloride salt? Here N attached with triple bond N, and there is what? Cl. This Cl acquires negative charge and the N acquires positive charge. This is called benzene diazonium chloride salt. Called what? Benzene diazonium chloride. Student, it is one of the very important and highly reactive reagent. With the help of these reagents, we can produce large number of compounds like many azo dyes, phenols can be prepared by this compound. Here we are dealing the preparation of haloarenes, so we have to concise only up to preparation of haloarenes. Means after first process, second process, that is this reaction. What? Benzene diazonium chloride salt. This is N, triple bond NCl will react with CuCl, or you can also react it with what? CuPr to form chlorobenzene or bromobenzene. Like I am writing the reaction only for what? Chlorobenzene. Okay. So this is the most important reaction. Plus what? N2. Getting? And plus you can write Cl or HCl. One more reaction is there. This is called again Finkelstein reaction. Finkelstein reaction. Earlier we have seen this reaction belongs to what? Halogen exchange. Means a halogen exchange reaction when chloro or bromobenzene. Okay. Therefore I am writing what? X. So X should be chloro or bromobenzene. When treated with sodium iodide, then exchange of halogen takes place, means X enters here and I enters here, thus forming what? Iodobenzene. This is iodobenzene plus NaX. Remember, X should be Cl or it should be Br. Student, you can write one more reaction. This reaction is known as Hunts-Dicker reaction. Hunts-Dicker reaction. Now, what is Hunts-Dicker reaction? In earlier topic, we have seen silver salt of fatty acid. So, in Hunts-Dicker reaction, we can take aromatic compound. Aromatic compound means, say, benzene, COO, and what? Ag. That is sodium benzoate. Silver benzoate. When treated with Br2, it forms bromobenzene. This is what? Bromobenzene. So the reaction is just like in the previous video I explained. So these three very important reactions belonging to the preparation of haloarenes. First one what? Selmer reaction. It plays very important role. You have to prepare proper notes. You have to learn it properly. Okay, you have to write down the chemical formula, name of reactant and product. You must have to give proper attention in the reaction condition, that it must be 0 degree to 5 degree. Why? Because HCl and NaNO2, these two are highly reactive reagent. So immediately the NO2 gas is getting evolved as soon as we mix these two. But remember, we are taking the mixture of these two to react with aniline, not with themselves. Okay, although they also react, but the gas is not getting evolved. Therefore, the formation of benzene diazonium chloride salt. Okay, you can write it what? Salt becomes easy. Why it is called salt? Because there is plus charge and minus charge. Therefore, this is called what? Salt. Get it? Second one is what? Finkelstein reaction. In previous video, we have seen for haloalkane called what? Halogen exchange. The third one, Hunts-Dicker. This is also belongs to same reaction. Here what? Silver salt or aromatic, okay, compound, that is called silver benzoate. Okay, silver benzoate treated with bromine, it forms bromobenzene.